Hello dear students. In the previous class, we discussed about representation of an atom and how to find out electrons, protons, neutrons in given atoms, molecules and also in ions. In this class, we are going to discuss about what are ions, how they are classified, how to remember ions very easily, and how to write chemical formulae for the given chemical compounds by using crisscross method very easily. Ions are also called as radicals. Ions are classified into two types. Those are called cations and anions. Cations are also called as basic radicals. Anions are also called as acid radicals or acidic radicals. First, what are cations? What are basic radicals? The positively charged species which are formed by the loss of electrons are called cations. Cations means what? Cations also called as basic radicals. Cations always will be formed by the loss of electrons. So, positive charge will be generated. In the same manner, anions are a negatively charged particles. These negatively charged particles generally will be formed by the gain of electrons. Then how to anions will be formed by gain of electrons and how cations will be formed by the loss of electrons, we will see now. These are the monoatomic cations. Before going to discuss about the monoatomic cations, first we have to focus on the noble gases. These are the group 18 elements in the periodic table, also called as noble gases, also called as inert gases. Right? So, inert gases, noble gases are helium, neon, argon, krypton, xenon, radon, organism. In the periodic table, these noble gases present in group 18 and helium present in first period. In the second period, neon, argon in third period, krypton in fourth period, xenon in fifth period, radon in sixth period, organism in seventh period. So to remember ions very easily, first we need to know noble gases along with their atomic numbers. What is the first noble gas? Helium. Helium atomic number is 2. Neon atomic number is 10. Argon atomic number is 18. Krypton atomic number is 36. Xenon atomic number is 54. Radon atomic number is 86. Organism atomic number is 118. So these all noble gases are said to be stable because if we write the electronic configuration for these noble gases, in every noble gas except helium, last shell is having 8 electrons. So we can say it is attaining octet configuration. So in the last shell, 8 electrons present, then that is said to be exhibiting octet configuration. Any element is having octet configuration, that will be said to be stable. So only in helium, 2 electrons will come in first shell. It is called doublet configuration. If any element is attaining doublet configuration like helium or octet configuration like other noble gases, that element or that ion will be said to be stable. Right? Come to the ions now. Lithium ion. Lithium. What is the lithium symbol? Lithium symbol is Li. Lithium atomic number 3. We know that according to the previous class, we know that lithium atomic number is 3. Lithium atomic number 3 means lithium is having how many electrons? According to previous class, we know that lithium having 3 electrons. Okay. So what is the nearest noble gas to the lithium with respect to atomic number? You check once. Lithium atomic number is 3. With respect to atomic number, which noble gas is present nearer to the lithium with respect to atomic number? Helium. So lithium atomic number 3, it is having 3 electrons, but helium having 2 electrons, it is said to be stable because of doublet configuration. So to get stability, lithium has to lose 1 electron to get helium configuration, to get stabilized. Right? So lithium having 3 electrons, no? To the lithium nearest to noble gas is helium. Helium is stable, but lithium is not stable. That's what, to get stability, lithium lose 1 electron to get 2 electrons. So if lithium is losing 1 electron, then it will get 2 electrons, no? So it will be stable. So to stabilize, lithium loses electrons. How many electrons it has to lose? To 1 electron only to get a helium configuration, to get stability. It is losing 1 electron, losing one electron. Losing means positive charge will come. Lose of electrons gives cation, no? Positive charge, no? That's all. Like that, for lithium, 1 plus will come. Sodium. What is the symbol of sodium? Na. Sodium atomic number is 11, we know according to previous session. It is having 11 electrons, right? So it is unstable. So related to sodium, nearer to sodium, which noble gas is present with respect to atomic number? Neon. Neon having 10 electrons, sodium having 11 electrons, right? So if sodium is also having 10 electrons like neon, it is also said to be stable, no? That's what. To stabilize, sodium loses 1 electron to get to 10 electrons, so to attain stability. So sodium loses 1 electron to get the neon configuration to get the 10. So it is also having charge 1 plus. In this manner, by comparing with noble gases, we can write the charge for these all elements very easily without by hurting. Next, potassium ion. Potassium atomic number is 19. 19 nearest 19 is unstable, but nearest to an 18 is stable, no noble gas. So to get argon configuration, it has to lose 1 electron, so 1 plus. Next, beryllium atomic number is 4. With respect to atomic number, beryllium nearest to noble gas is helium. So to get helium configuration, beryllium loses 2 electrons, that's what 2 plus. Magnesium atomic number is 12. So nearest to noble gas is 10 now. So to get neon configuration, so it loses 2 electrons. So charge is 2 plus. Calcium ion atomic number is 20. For to the 20 nearest to noble gas is argon. It loses 2 electrons, 2 plus. Aluminum atomic number is 13. So nearest noble gas is neon 10. To get neon configuration, it has to lose 3 electrons. So 3 plus will come here. And finally, hydrogen ion. Hydrogen, generally hydrogen atom, if we take atomic number is 1, mass number is 1. According to previous class, so hydrogen is having 1 electron, 1 proton and 0 neutrons, right? So if we write H1 plus after losing 1 electron from hydrogen atom, then it is having, according to this you tell now, it is having 1 proton only, 0 electrons. Because it is having 1 electron, it loses, know that one, 0 electrons and 0 neutrons. So only 1 proton is present in H1 plus. So that's what H1 plus is also called as a symbol of a proton. What is the proton symbol? H1 plus. Why we are telling proton symbol is H1 plus? Because in H1 plus only 1 proton present. There is no neutron, there is no electron because of that. Right? So hope you understand how to remember the cations very easily without by heading. These all are called monoatomic cations. Why these are called monoatomic cations? So because in every ion you see clearly, in every cation, all are positively charged species, all are cations. In every cation, only one atomic symbol is present. Lithium, 1 atom, sodium 1 atom, potassium 1 atom, beryllium 1 atom, magnesium 1 atom, calcium 1 atom only, aluminum atom, hydrogen atom. For example, if you take NH4 1 plus, it is not a monoatomic cation, it is a polyatomic cation because here nitrogen symbol is present, hydrogen symbol also present. It is a polyatomic cation. But these all are the examples of monoatomic cations. Now monoatomic anions. So anions also like cations, you can remember easily. So by comparing with the same noble gases again. See for example fluoride ion. Fluoride ion means related to fluorine atom, no? So fluorine atomic number is 9. 9 is nearer to which noble gas? Neon. So neon 10 electrons stable, no? So to get stability, 9 electrons becomes to 10 electrons by gaining 1 electron. So it gains 1 electron. So 1 minus will come. So in the same manner, chlorine atomic number is 17, no? It will gain 1 electron. So 1 minus to get the argon configuration. Right. Next, oxygen atomic number is 8. 8 nearest to noble gas is again neon. So it has to gain how many electrons to get the neon configuration? 2 electrons. So 2 minus will come. Sulfur atomic number is 16. To the 16 nearest noble gas is again argon. So to get stability, sulfur gains 2 electrons to get the argon configuration, to get the stability. So 2 minus will come. Nitrogen atomic number is 7. 7 nearest noble gas is again neon. So it has to gain 3 electrons now to get stability like a noble gases. So 3 minus will come. Phosphorus atomic number is 15. So it has to gain 3 electrons to get the argon configuration. So 3 minus. And finally, hydride ion. Hydrogen atomic number is 1. It has to gain 1 electron now to get helium configuration. So H1 minus will come. So in this manner, we can remember anions also very easily by comparing with the noble gases. Okay, these all are called monoatomic anions. Everywhere single atom only present, no? That's what these all are called monoatomic anions. And one more point is fluoride. So you observe the common point here. Fluoride, chloride. Everywhere IDE is coming, no? What is it indicates? Whenever in the given ion, IDE is given at the end of the name, which means that in the symbols of those ions, so only single letter will be there. Single letter, sorry, not a single letter, single symbol. Fluorine, chlorine, oxygen, sulfur, nitrogen, phosphorus, hydrogen. Right now? But except one hydroxide ion, OH1 minus. Here also IDE will come, but two symbols will be there here. This one you should remember as an exception. For remaining, it is applicable. Whenever IDE is coming, it indicates there is a negatively charge present here, and in the symbol, single atom symbol will be present. Hope you understand. In case of cations also, one common thing is IUM will come. IUM is given. It indicates that it is a positively charged species. Okay. For example, till now we discussed list of some cations and list of some anions, right? Now by using that list of cations and anions, we can write the chemical formula for the given compounds. For example, sodium chloride. So what is the formula of the sodium chloride? By using the crisscross method, we are giving the chemical formula for the given chemical compounds. Now, sodium chloride. What is the formula of the sodium chloride? Sodium, you divide this compound into different ions. Sodium ion and chloride ion we can observe here. What is sodium ion? Na1 plus. What is chloride ion? Cl1 minus. Then you write like this: sodium 1 plus, no, without sign you write 1 here. Chlorine 1 minus, no, you write 1 here. Apply crisscross method means so the number related to chlorine you write along with sodium, and the number related to sodium write along with the chlorine. So Na, this one is going to sodium 1, no, this one is going to chlorine Cl1, no. So 1 means no need to write. Directly we can write NaCl. So sodium chloride formula is NaCl. Second example, you see potassium oxide. There is potassium ion and oxide ion. What is potassium ion? K1 plus. What is oxide ion? O2 minus. So potassium ion K1 plus, no, K and 1 you write here, and oxide ion O2 minus, no, 2 you write here without signs. So apply crisscross method. Oxygen number 2 apply to potassium, and potassium number 1 apply to oxygen. So K2O is the potassium oxide formula. Right? Hope you understand. One more example. Magnesium nitride. Magnesium nitride. There is a magnesium ion and a nitride ion here. What is magnesium ion? Mg plus 2. What is nitride ion? N3 minus. So magnesium number is 2 and nitrogen valency number is 3. So apply crisscross method. So Mg3 N2 is the magnesium nitride formula. And one more, aluminum oxide, having aluminum ion and oxide ion. Aluminum ion is Al3 plus. Oxide ion is O2 minus. Aluminum valency is 3, oxide valency is 2. Apply crisscross method. Al2O3 is the correct formula for aluminum oxide. Hope you understand.